let's talk about some general principles of sorting. So when we're making things or selling timber, we will have a certain population of timber, and we want to be able to divide that up according to some property that will help improve its value. That's the whole point of sorting, is to improve the value. So we want to separate that population out into the better stuff from the worse stuff, according to some property that we care about. So we'll need some criteria on which to make that decision. Now, the property that we care about might be a mechanical property like strength, it might be a physical property like density, it might be a property like durability, it could be anything really. But I'm going to draw it as if it was a numerical property, just for simplicity. So we'll have that property and certain levels of it, and we'll have some criteria on which we make our decision. And there needs to be some kind of relationship between the two. I'm drawing it like it's a linear relationship, but it need not be linear. It need not even be a continuous numerical function. It just needs to be some criteria, and on one side there's a higher level of property than on the other. So in principle, all we're doing is kind of picking a threshold of the criteria that we're sorting so that we can separate out the stuff with the better properties from the stuff that has the worst properties. Now, the important thing about species is that it not just affects the level of the property, it will also affect the relationship between the property and the criteria. So, for example, the relationship between stiffness and strength for spruce is different than the relationship between stiffness and strength for oak, for example. But the other thing that can affect this relationship are the growth conditions. So oak in France would have a different relationship to oak grown in the UK. And that's partly because of the different climate, partly also because of different forest management.